So this video should be an update on what I've been doing the last weeks. And the first thing, probably the least interesting, is Denali got some refactoring going on. Some context struct with a global root variable that you can set. So now, for example, in older API, you had to do, for example, load from and some other methods probably didn't have the from argument. So now the whole thing could be just called against root. Root is the global parameter that you can set, and it's just going to work. At least I hope it will. And the other thing is no more functions with 200 lines of code in them. I just split some functions, basically some added some other things among the other. I don't really remember all of them because it was like a week ago, but yeah. And another important thing that I wanted to talk about is templates. So the way I like to think about templates is it's basically the workspace you like, just saved, you know. So the basic idea is, for example, you're working in C, you have a make file that you use like almost always. It's your universal make file. You have some structure, some folder structure that you use almost always. And you could just snapshot it as you would a project, for example, and you could just restore it. It is basically what the template is. And another cool feature of templates is they could call commands. Uh, oh, and actually, another important thing is Denali got support for permissions, for POSIX permissions, really. So the old way that the files were handled is basically you have a magic number for files, magic number for folder, and magic number for cell. Now, the new way to save it, we're going more like get. I'm basically copying the POSIX bytes, or, well, yeah, bytes, bits. Basically copying the POSIX signature and saving it with the files object in the tree. But a bit differently than get. I'm not saving the octal, I'm basically just dumping the bytes into the file and hoping nothing breaks. Yeah. And back to templates. Templates can call commands. Really. So say for example you have a, I don't know, a project, a web project, for example, where you use Node package manager npm, and you need to call npm install each time, or you need to call, I don't know, npx create project name. And the template could call those commands for you, provided that you have them in your system installed. And another cool feature of this whole thing, the templates, the commands, you can have a placeholders, really. So placeholders are basically values provided by user that you can use in the commands. For example, if you have, I don't know, something that depends on the name, I don't know, you're creating a container with the name and you want to provide that name by hand. For example, it depends on your project name and you want to type it each time you create a template of your project, then you can just do it. You need to add placeholder name into the placeholders array, and then you can just use that name with a wrapper. You can wrap the name provided in placeholders into this, and it's when you restore the template, you're going to be prompted to provide the value for that placeholder, basically. And then the value you've provided is going to be used to do whatever commands you needed to do, basically. So now, apart from Denali, Uh, I'm trying to, build projects in rotation, 1 week of one project, another week of the other project. So apart from Denali, I worked a little bit on the OS. I just ported it to UEFI. Yeah, added a frame buffer, by the way. This is something that I wanted to do much earlier, but I wasn't able to do that because of legacy bias and my lack of knowledge, probably. And so, yeah, I switched to UEFI. I used UEFI REST crate because I'm used to work with Rust and probably a newer API, I'd say. Like looking at C library, I don't really remember the name of it. It was really bad. Like I didn't understand half of what was happening with the thing, because there are some types that are capitalized. There's the main function except some, I don't know, parameters. What the hell is going on? So I decided that I don't want to go there. I want a simple API, and I chose Rust. Yeah, the only problem I had with it is like adding a compile target for Rust C, which apparently was really hard to do on NixOS, since I don't use Rastup because Rastup is not true NixOS way. It's not declarative. And I wasn't able to make it work globally, but I at least made a small Nix shell where everything works. So if you're using Nix, you can use the Nix shell provided. You can just call Nix develop in the root project directory and you're gonna be good to go, basically. And another big thing that I was able to achieve because of shifting to UEFI is memory mapping, dynamic memory allocation. Yeah. So why was I not able to do that with legacy bias? Well, again, skill issue probably. Because I didn't want it to map memory in goddamn assembly. God forbid the assembly. I don't know how to do that. I'm really not that skilled. And again, in UEFI, especially in Rust, crate for UEFI, you can just do that. I don't know. They have memory type, and you can just choose what memory type you want to add, and basically that's it. And the thing about dynamic memory allocation, if I'd probably explain it a bit. So basically, what happens, the bootloader provides to the kernel a bunch of different entries. So you have the start address of the entry and its size in the memory. So one entry could point to, like, I don't know, 1 MB, and its size could be like, I don't know, 2 to 5 MB, or maybe even gigabyte, for example. And you then map those entries because you can't just allocate out of nowhere because you risk into conflict. And so, in order for you to not do that, in order to have like kmalloc, the k3 command, you need to have some way of knowing what memory is occupied and which memory is free. And the basic way of doing it, as I did, is just a bitmap of the whole memory. You basically divide the memory into 4 KB so-called pages and just map them in the bitmap and look up. For example, if your kernel, I don't know, needs like 1 MB of memory allocated for it, you could just ask for it in physical memory manager. And so in order to allocate memory, you basically just look up the bitmap, which is an array of ones and zeros, basically. And you just look up where the entry is 0 and just return the address of that entry. That's it, basic idea. And if the entry is 1, then it's occupied. You can't return this memory, or otherwise you are risking some conflicts. Yeah, that's it. And then hip, on top of that, hip can manage the pages allocated for the hip. So say your basic size for the hip is 1 MB, and hip decides how programs can use these 256 pages between them. Like, for example, for the basic way hip works, the probably I'm not sure it's the easiest way, but I believe it's one of those not too hard to implement. It's basically a linked list of free blocks. So the 1 MB, we don't treat it as the pages anymore. The physical memory allocator treats it as pages. The hip doesn't treat it as pages, it just treats it as continuous memory. It knows that it has the start address and the 1 MB of total memory that it can use. And so what it does, it creates a big chunk that is called free block, which basically occupies the whole thing, from starting from 0 to 1 MB, and then it manages this memory between programs. For example, if you needed the, I don't know, only like 5 KB to allocate, then the hip would split this free block and return to you a piece that you actually need, like 5 KB. So the cool thing about it is basically these free blocks are a linked list that connects, and I've never worked with linked list, honestly. That's probably my first time working with linked list. Mm, yeah, that's basically it. I think that's all I did. I'm also planning to rewrite the file system API on my operating system because at the moment it's a little bit shitty. It's not good. And basically I'm aiming for the standard Unix again, for standard Unix API for file system interaction, which is basically like fs open, fs write, fs read, I don't know, fs seek, maybe, and all that stuff. I tried it early, but it failed. So I decided, screw it, I'm gonna rewrite it. But I didn't have enough time to rewrite it by the time I'm recording this video. So, um, yeah, probably another week of work. So, yeah, goodbye.